G'day team, and welcome back to yet again another video. And today we're going to look at a bit more of this probability distribution function stuff and more of the statistical properties that we can actually find from these PDFs. So you can see we've got the typical 5 that we usually find with stats: the mode, the median, the mean, the variance, the standard deviation, things that you've been looking at for a long time now. So when we're looking at it in terms of our PDF, so our integrals of our function, the mode is the value of x that maximizes f of x over our domain. Now, utilizing your graphics calculator and graphing the function is the easiest way to do that. You could differentiate the function, solve it when it's equal to 0, but in an exam situation, you're probably just going to graph it and find the maximum. The median value of m, so the middle value, is the value such that from a to m, so our lowest limit to m, of our probability distribution function with respect to dx is a half. So it's smack bang in the middle, so the probability of it occurring is right in the middle. The mean, the expected value of x, or mu, is the integral from a to b of x times f of x dx. And we'll look at what we do when we see that, because often it gets a little bit tricky, but we're going to just distribute that. But we'll look at that in a moment. Now the variance. So the variance of x is the integral from a to b of x squared times f of x dx minus the mean that you found. So you do need the mean to find the variance. And then the standard deviation is just the square root of your variance answer. Now both formulas would work here. Typically this one's going to be easier to use because this integral is way easier to solve than this one here. But you might already be given that mu value and it might be an easy function to do. So just keep it in mind. So we're going to roll straight onto an example. Now I've got all the good stuff here. So x has a probability distribution function f of x equals k over 2 root x on the domain 1 to 4. Now part A, we're going to find k if f of x is a valid PDF. Now if you graph sort of any form of k over 2 root x, you get a positive function, so we don't have to worry about that. We'll just solve the integral to equal 1. I'm going to find the mean, find the median, and then finally find the mode. So let's start off by finding k if f of x is a valid PDF. Now, what we need to do is integrate it. So we're going to integrate, so this is part A, we're going to integrate from 1 to 4 of k over 2. Now I've got root x on the bottom, so I'm going to bring that up as x to the minus 1/2 dx, and now it's in a form that we can easily integrate. So, and we're saying that's equal to 1 because it's a valid PDF. So this is just a polynomial, add 1 to the power, divide by the new power. So in here, I've got x to the power of 1/2. K over 2 divided by 2 is just k. And I've got 4, 1 equals 1. Now remember, x to the power of 1/2 is just the root of x. So therefore, use my therefore signs, I've got the square root of 4k minus 1k equals 1. So 2k minus k equals 1. That's a square root there. K equals 1. So therefore, f of x equals 1 over 2 root x. So our nice basic form there. All right, that's k. Let's do part B. Now part B is find the mean. So we roll back up here. We can see we multiply our function by x and solve on our total limits. So from 1 to 4 of x times k on 2 x to the negative 1/2. Now I'm going to keep it in that form because, as you can see, we're going to utilize some index laws. Now we can take that constant out the front. I didn't do it last time, but it will help us tidy up what's happening in here. So if I take that k on 2 out the front, I'm left with x times by x to the negative 1/2. We add the powers together. I'm left with x to the power of 1/2 dx. So let's integrate that now. I've still got my k on 2 out the front. X to the power of 1/2 is 2 over 3 x to the 3 over 2. So we've raised the power by 1, divided by the new power, which is the same as timesing by the flip. Now that's 4 and 1. But I just realised we already have k. It's just a half, isn't it? So we don't actually need k there. It's just a half out the front. That's just me being a bit silly. What you could do from here is actually just use it, do it on your calculator. All right, we're going to do it by hand, but it's a definite integral. You can always use your calculator. So I've got 1 over 2 right out the front. 2 over 3. Now, x to the power of 3 over 2 is x root x. So I've got 4 times the square root of 4 minus 2 on 3, 1 times the square root of 1. Okay. Slowly roll through. I've got a half. 4 times 2 is 8. 8 times another 2 is 16 on 3 minus 2 on 3, which is a half, 14 on 3, and we multiply them through 14 over 6. So just like that, we have our mean. So what I could be doing here as well is having my mu coming along for the ride. All right, part C, we're going to find the median. Now the median is the value of m such that the integral from a to m of f of x dx equals a half. So I might just move this one over a little bit and I'll come up here. So we want the integral, so median, we want integral from a to m. So a in this case is 1 to m of f of x. Over here I can change that to a 1 as well. A half x to the negative a half dx. And that has to equal 1/2 for the median, okay? So the median, okay, we raise that to 1, so that's going to be x to the power of a half, which is just root x. M1 equals 1 over 2. So the square root of m minus 1 equals a half. Square root of m equals 3 over 2. M equals root 3 over 2. So that tells me my median value. Cool. All right, so there's the median. And finally, the mode. Now, like I said, mode is the one that maximizes f of x. And if you look at our function, I'll draw a little quick sketch. Kind of comes around and starts about here and just goes like that. So 1 to 4. 1's going to give me my max. So the mode equals 1. Just like that. Hopefully that is helpful and it's a good example to roll through. Like I said, you can do it on your calculator. It makes life way easier. So in a test situation, unless the question says otherwise or has an unknown like this part, use your calculator. You should be checking on your calculator anyway. But anyway, thank you for watching and we'll catch you in the next one.